we can use logical operators to combine Boolean expressions. Say that we have a small program like this where we have two integers of different size, a Boolean named b, and we assign a value to b based on the Boolean expression that evaluates whether or not num1 is less than num2. Obviously, we can see that this Boolean expression should evaluate to true, as num1 is indeed smaller than num2. Now let's try and introduce logical operators. I'll start by introducing a few new variables. I'll make a num3 and give it a value of 23, and I'll also make a num4 int and assign that a value of 24. The important part here, of course, being that num4 is larger than num3. Now, down here, I can have another logical expression with those evaluated together with this Boolean expression here by using a logical operator. A logical operator could be one like the logical AND operator. So if I introduce that, and then on the right side of the logical AND operator introduce a Boolean expression like this, we have here a combined Boolean expression that will return either true or false. As opposed to before, now there are two Boolean expressions that are evaluated. First, this one over here is evaluated on the left side, and if this one turns out to be true, this one over here will be evaluated. If this one also turns out to be true, the combined Boolean expression here will return true. And the reason that they both have to be true is that we have used the logical AND operator that requires that the expression on the left and the expression on the right needs to be true in order for the combined Boolean expression to return true. Now we can try and run this program. As we see, we didn't do any changes to this one, so this one should still evaluate to true. Over on this side, we have num3 less than num4. This should also be true, so we would expect that this program would evaluate the Boolean expression here to true, because this fulfills the conditions presented by the AND operator, and thus the value assigned to b should be true, and that should be the value that we get printed out down here. So let's see what happens when we run our program. And we see that again this program evaluates to true. Now we could try and validate that this is indeed how the AND operator works by flipping the less than sign to a greater than sign. Now obviously num3 is not greater than num4, so this logical expression here should evaluate to false, and thus the combined logical expression here, or the combined Boolean expression here, should evaluate to false, as this does not fulfill the criteria presented by the AND operator. Let's check. And we see that is true as well. So, of course, the output is false, but what we set up here was true. So this means that if both sides of the logical expression where we use an AND operator is not true, well then false will be returned. We could try and replace the AND operator with the OR operator to see if that will change anything. With the OR operator, we recall that only one of the expressions needs to be true in order for the OR operator to return true. Now this side over here we didn't do any modifications to, so this one should still return true, and as a consequence the entire Boolean expression here should return true regardless of what we have here on the right side. So let's see what happens. And we see that this is in fact what happens. If I change this one over here to a less than sign again, so they both evaluate to true, we see that this won't make any change, as the OR operator only requires us to have at least one true. If we wanted only one true, what we could do instead is we could introduce the XOR operator. The XOR operator looks like this. Now the XOR operator specifically states that you can only have one of the sides, exactly one of the sides, to be true in order for this Boolean expression to evaluate to true. So let's see if we get a false returned here. This is exactly what happens. So now we can try and flip this one again to make sure that the right hand side of our combined Boolean expression here evaluates to false, and see that this actually results in or combined Boolean expression returning true. So now we validate the truth tables of our AND and our OR and our XOR operators.